Sequences, a topic of advanced calculus which serves as a base for real analysis. So starting with this sequence, a sequence is a function whose domain is set of natural number and range can be any set. Means it's a function in which we'll substitute the values as natural number and so answer we can get any kind of sets. So it can be real or complex in case of just sequences, but we'll be studying only the real sequences, which I'll be discussing in a minute. So it is denoted by an in curly braces or in these triangle braces, a1, a2, a3, an and so on. An is the nth term of the sequence. F is defined from n to s. N is natural number. S can be any set right now. For example, f of n is equals to 1 by n. I'll be substituting natural numbers, so I'll be getting the values as 1, 1 by 2, 1 by 3 and so on. Real sequences is a sequence where the s is a subset of real numbers or the real number itself. So we are confined to real sequences only in real analysis. So f is defined here from n to r. The value will be substituting as set of natural number and answers will be getting as only real numbers. As the examples I have written above, 1 by n is a real sequence. Real sequence is a function whose domain is set of n of natural numbers and range be any subset of real numbers. So I'll be using the term only sequence here, which will in turn means we are talking about real sequences only right here in analysis. So range of sequence, the set of all distinct terms is range. Like in the above example 1, 1 by 2, since all the terms were distinct, so the range is the whole set. If I take the example of the sequence as minus 1 to the power n, I'll be getting elements as minus 1, 1, minus 1, 1. These are the repeating elements, so range is only minus 1 and 1. Constant sequence means there is no n in the nth term. It's free from n. A sequence is such that for every n it is fixed value, whatever it is, but it is fixed. Like here I have taken an is equals to c. C is any real number for all n belongs to n. For example, if I take c as 2, sequence will be 2, 2, 2. For every term it's 2. So range is 2 only. Bounded and unbounded sequences. First of all, bounded above sequence. A sequence an is said to be bounded above if there exists a real number k such that an less than equal to k for all n belongs to n. Means sequence is bounded from the upper side. Range of the sequence is bounded above. For example, if I take suppose the above constant sequence I take, all the term is less than equal to 2. So the sequence is, this particular sequence is bounded above by 2. If I take the example of 1 by n, all the terms are less than 1. An less than equal to 1. So it is bounded above by 1. Suppose I take example of minus 1 to the power n. The terms are minus 1 and 1. All the terms are less than equal to 1. So 1 is the upper bound. Sequence is bounded above by 1. Next is bounded below sequence. In a similar way, a sequence an is said to be bounded below if there exists a real number k such that small k I am taking here just for different representation, small k less than equal to an for all n belongs to n, means the range of the sequence is bounded below, bounded by the lower side. For example, I am taking the similar example to clarify. 1 by n, see all the terms are approaching towards 0. So all the terms are at least positive, greater than or equal to 0. They won't be equal to 0 because we won't put n is equals to infinity here. So all the terms are greater than equals to 0. Sequence is bounded below by 0. In case of minus 1 to the power n, all the terms are greater than equals to -1, sequence is bounded below by -1. In case of the sequence n, suppose the sequence is 1, 2, 3 onwards, all the sequence members are greater than equals to 1, it is bounded below by 1. Now the bounded sequence is a sequence is said to be bounded which is both ways, bounded above as well as bounded below. If it is bounded above as well as bounded below, means there exist two real numbers small k and k, small k and k. Small k is less than equal to capital K. Mostly they are less, or at the most they can be equal also. I'll tell you the case in which they are same. So here is the definition is combined format of above and lower bound, bounded above and bounded below sequences. So this is the example of constant sequence where it is the case when small k and capital K both are same. Sequence is bounded above by 2 also, sequence is bounded below by 2 also. So this is bounded. -1 to the power n is an example where it is minus k, small k is -1, capital K is 1, sequence is bounded. Here it is bounded because it is bounded above and bounded below both by 2. All the terms are less than equal to 2 and greater than equals to 2. This sequence is also bounded. 1 is the by which the sequence is bounded above, and 0 is the case sequence is bounded below.